Welcome to the Electronic Lab, Lab 8. Today is the second part of the BJT topic. In this lab, there are 3 experiments. Experiment 1. In this lab, we want you to verify the characteristic of BJT operation point by changing the base current and resistance at collector. Complete the circuit and measure VCE, VBE, IB, IC in the following conditions. Because the condition of RB and RC are very close in 1 and 2, therefore the result will be similar compared to the third condition. To measure IB and IC, use your multimeter and measure the voltage across RB and RC. Then use the voltage and resistance value to calculate the current. Do not use the oscilloscope in this measure. This graph is the illustration of the effect of changing RB and RC. Changing the RB will change the IB, which surely changes the operation point. And also, the slope of this line is related to RC. Therefore, changing RC will change this line, which will also change operation point. Experiment 2. In this experiment, we want to compare the stability of different circuits. Therefore, we will configure the circuits to its maximum output and observe the impact of changing the beta. Complete the circuits and adjust RB such that the VCE equals to 5 volt, then record the RB. Record the DC condition of the circuit by measuring VBE, VCE, IB, and IC, and beta without any input signal. After this, input a sine wave signal with frequency 10 kHz and the Vout peak to peak equals to the maximum value without output waveform distortion. We define that distortion to be the signal being cut off. Therefore, the left figure is considered to be a non-distorted signal, while the right figure is considered to be a distorted signal. Record the maximum VI, Vout, and the waveform. Then we will replace the BJT with beta variance greater than 10 and test it under the same condition. Repeat step 2 and step 3 and also calculate the difference of VCE. Repeat these steps for each circuit to test their stability. The reference data for RB of these circuits are listed here: 330K, 30K, and 1.1 megaohm. And here's a reminder. Since the circuit of experiment 3 is the same for this one, we suggest you to do experiment 3 right after you've done the measurement for the second circuit. Experiment 3. In this experiment, we want to illustrate the effect of the bypass capacitor. Complete the circuit and adjust RB such that the VCE equals to 5 volt. Then record RB. Input a sine wave signal with 10 kHz and peak-to-peak voltage equals to 20 millivolt. Record the VI, Vout and calculate the voltage gain. For the bonus lab, record the frequency response of the circuit. Then add a bypass capacitor between emitter and ground. And repeat step 2. Then change to another capacitor and repeat step 2. Basically, the RE helps us to stabilize the DC part of the signal, but at the same time it will harm the gain of small signal. Therefore, by adding a capacitor, the small AC signal is grounded, and the DC signal will still be stabilized with the RE resistor. For the bonus lab, use the AC sweep to measure frequency response. The following slides are from the previous labs to give you a review of frequency response measurement. You can see that in this graph, without the capacitor, the gain is small, but with the capacitor, the gain of higher frequency gets larger, which verifies our guess. That's all for this lab. Then we have 2 notifications for you. Next week, we're going to have the final exam with paper test and experiment for about 2 hours. These are the topics of this lab that you should study. As for the coming final project, we'll implement the speaker. That's all. Good luck.